I've been asked to do another polypeptide at an acidic pH so that we can see how that works, and especially one with a histidine in it. And so the one that I'm going to do is Flaherty, and I need to make sure I have my pen. So we've got Flaherty. Okay, so we have our polypeptide. Remember, when we write it down, we need to put our termini. So we have our N-terminus, and we know that it has protons of some sort. And then we have our C-terminus, which may or may not have protons. Remember that I always like to write the pH that I'm working at, so I'm going to write that at the top, although that looks goofy because I've got it too close. So, pH, sorry guys, 1.0, there we go. Okay, so pH 1.0. And we'll write in all the pKa's, right? So I'm going to put that here and say that that's what all these are. The pKa of the N-terminus of any polypeptide, we're just saying, okay, it's around 9. We're just going to go through the polypeptide and identify the nature, or the names of the amino acids in it. F is phenylalanine. It is aromatic, so it has no dissociating proton. Leucine, or L, is aliphatic, or just simply hydrocarbons, so it doesn't have any dissociating protons. Alanine has a side chain that's a methyl group, so it has no dissociating protons. It's aliphatic, or just hydrocarbons. Histidine has that imidazole ring with nitrogens in it, so it does have a pKa because it does have a dissociating proton, and that is 6. It's a terrible 6. E is glutamic acid. It's got a pKa around 4. Arginine has a pKa. Remember, the side chain of arginine is a guanidinium group, a central carbon with 3 nitrogens attached to it, and one of those nitrogens attaches to the rest of the side chain. So its pKa is around 12, so 12.5. Oh, this is not working. 12. And then T is threonine, and threonine is a polar side chain. It has a hydroxyl group on the as the side chain, or part of the side chain, and so it's got a pKa of around 13. And then Y is tyrosine, which is a benzene ring with a hydroxyl para to the connection to the rest of the side chain, and so its pKa is around 10. And then finally we have the pKa of the carboxylic acid terminus, and that has a pKa of around 2. Okay? Alright, so now we're ready to rock and roll. So we have a pH of 1. So we have a pKa of 9 for the N-terminus. The pH is less than the pKa, and when pH is less than pKa, things are protonated, and nitrogen will take on 3 protons. When it's deprotonated, it has 2. When nitrogen has 4 bonds to it, it's positively charged. We'll have to jump in 4 amino acids to histidine, and the imidazole ring, when it is deprotonated, it's neutral. When it's protonated, it's positively charged. Remember, your imidazole ring has 2 nitrogens in a 5-membered ring that's aromatic, and so when the pH is less than the pKa, things are protonated, and when an imidazole ring is protonated, it is positively charged. The pH of 1 is less than the pKa of 4, and so our carboxylic acid on glutamic acid is protonated. And remember, when carboxylic acids are protonated, they're neutral, so this has no charge. No charge for you, you go on through. Arginine, our little pirate amino acid, because it's arginine, has the pKa of 12, so the pH is less than the pKa, so this one also is protonated. Arginine takes on a single positive charge, excuse me, and so we have that charge. Threonine has that hydroxyl, and when hydroxyls are protonated, they're neutral. When they're deprotonated, they're negative. of course. And so the pH is much, much less than the pKa of 13. And so that one also is neutral. Let's see if I can draw this perfectly. There, look at that. It looks like a little heart. And then tyrosine has the aromatic ring and the hydroxyl. It's a phenol, basically. And it has that hydroxyl. So again, when a hydroxyl is protonated, it's neutral. pH of 10 is pH of 1 is much less than a pKa of 10, and so it too is neutral. Finally, I get to my carboxylic acid terminus. pH of 1 is less than a pKa of 2, so this one also is protonated. So I have an overall charge on the molecule of +3. Okay? So what have I got? I've got a positive charge on my amine terminus, my histidine, my arginine, and those are my three positive charges.